Okay, it is 10 a.m. on the dot, and it looks like most of the students are here, so I'm going to go ahead and kick this off and get us started. Welcome to Structural Analysis, everybody. I'm glad to have you here. I know that this is an interesting interface, shall we say, but I think we're going to have a lot of fun this semester. This is a really fun class to teach, and hopefully you'll get some good stuff out of it. What I want to do before we get kicked off into the content for today, which just so everybody's aware, today is mostly going to be a discussion of just the course operation. We're going to talk about the virtual software that we're going to use, as well as the syllabus, and talk about some background on the topic. Now, I noticed that somebody here in chat said that there wasn't any sound. Before I begin, can somebody either through audio or in chat, I want to see if it's just the one student or if it's everybody. Can everybody hear me? Okay. All right. Mr. Enon, I saw that in chat. If you're having some issues, I was going to say you might need to refresh your page. I was going to mention that there might be some issues. In fact, what I want to do before we get started actually getting into the discussion for today is, and I probably won't do this every day, but I want to go through the attendance roster, and I want to make sure that everybody can hear me and see the opening slide that says CE 312 Structural Analysis on the top and has the announcement and whatnot. So I'm going to go through the roster. You can either respond in the chat or through audio. Either one's fine, but we'll just take it one step at a time. Let's see, Mr. Adkins.
I am here. I can see the lecture.
Awesome. Okay, Mr. Ball. Okay, good. Mr. Blizzard.
I can hear you.
Awesome. Mr. Bauer. Mr. Bauer. Okay. All right, we'll move past him. Mr. Cochran.
Yeah, I'm here. I can see everything.
Awesome. Mr. Cooper. Awesome. Mr. Couvert. Okay, I don't see him on the attendance. Mr. Garcia. Awesome. Mr. Garrison. I see your name here in the chat. Awesome. Ms. Hudson.
I'm here and I can see.
Awesome. All right. Mr. Enoch, were you able to get back on? Okay, awesome. All right. Ms. Keaton. Awesome. Mr. Mitchell.
I'm here and I can see.
Awesome. Mr. Palmer Ramos. Wonderful. Mr. Randolph. Awesome. Mr. Riggs. Awesome. Mr. Romans. Mr. Smith.
I'm here and I can see you.
Awesome. Mr. Smirchinsky. How did I do? Good. Did I get that right, I hope? You can let me know at some point. Mr. Tadisi, did I get that one right? Good. All right. Mr. Thews. And Mr. Wise. Awesome. All right, let me check. There were two that weren't able to get back to me, but I don't see them logged in. So looks like everybody that's logged in can see and hear well. So we'll go ahead and get right into it. Like I said, what I want to do today is cover really three main topics. I want to cover, first off, the course operation, how we're going to do this via Blackboard, and some of the other tools and software that we're going to use throughout the semester. I want to go over the course operation, the syllabus, the grading, how we'll conduct the class. We'll go through the syllabus in more detail, and then we'll go into a little bit of a background on structural analysis, basically answering why you're even in this class, why this stuff is important. So I'm going to go ahead and move on to the next slide. Since we're doing this online, I figured I would tell you a little bit about myself. I think that most of you probably had me for a class like Engineering 103, but that's probably been a long time ago, and some of you might not have had me at all. So I'll tell you a little bit about myself. I'm an associate professor in the civil engineering department. I've been here since 2014. I did my PhD from that school up north. I got that in August of 2014 from WVU, and then I came here, and I've been here ever since. I'm a licensed engineer in West Virginia, and I'm a structural engineer. And my main area of passion is bridge engineering and steel design. That's really where I focus a lot of my efforts. I am married. That's my wife Becky on the bottom right, and I have one daughter. That's Stephanie. As you can see, her shirt says "Sweetheart." Is of course an immutable fact. She is absolutely a sweetheart. It's like there's some of forces, some of moments, and the fact that Stephanie's a sweetheart. Those are the immutable facts of the class. Like I said, I'm a bridge engineer, and a lot of my research is focused on highway bridges. I've been doing research on various aspects of bridge engineering for the past going on 10 years. One of my bigger projects has been the development of a press brake form tub girder. It's basically taking a large sheet of structural plate and bending it into a U-shaped tub and using that for highway bridges. This is just some images of some of the research that I've done on this. We've actually installed 2 of these in the state of West Virginia, one of these in Lincoln County, and one up in Marion County in the northern part of the state. So it's been some pretty exciting work, and that's really where a lot of my focus lies. I do a lot of work with the DOH, with the American Iron and Steel Institute. I'm also pretty active here on campus. I'm the advisor for the ASE student chapter, the SME ASE student chapter. I'm also the advisor for Theta Tau. I was a previous president of the West Virginia section of ASC. I'm also the current chair of the Faculty Advisory Committee for Students with Disabilities. So I'm a pretty busy guy, but I'm excited to be here, excited to have everybody in class, and hopefully we'll have some fun throughout all this. Let's get into class. Let's talk about technology tools that we're going to use for class. So obviously, one of the main tools that we're going to use is Blackboard, and everybody online is using that now. We're going to meet during each lecture at the scheduled time here on Blackboard. The way that I set it up today is the way that it's going to work throughout the remainder of the semester. So we meet Monday, Wednesday, Friday at 10 a.m. The session will open up 15 minutes prior, and we'll try and get started right at 10 on the dot. So as long as you're online by then, you'll be good. But I'm not going to use Blackboard just for that. Blackboard is really going to be the main interface where we operate the course. All of the grades are going to be posted to Blackboard. All of the lecture notes, all of the slides that I'm using for today are already posted on Blackboard. The homework assignments are going to be posted to Blackboard. You will submit those homework assignments via Blackboard. We'll also do the exams via Blackboard. So like I said, Blackboard's going to be the main tool that we use for the class. Make sure and check your Blackboard daily, and we'll talk about the homework schedule later on. But like I said, we're going to be using Blackboard very frequently. I sent an email to the class late last week discussing Cam Scanner. And first off, if you have a printer scanner combo at your house or your apartment and you want to use that to scan in your homework assignments, that's completely fine. But we are going to be doing homework, a fair amount of homework in this class, as you would any engineering course. And what'll probably happen is you'll do the homework on paper and then you'll need to turn it in. By and large, the easiest way to do that if you don't have a printer scanner combo or something like that at your house is Cam Scanner. It's a mobile app that's available on Apple and Android. So I would imagine most of you probably have smartphones, and if you have that, you could download the Cam Scanner app. And basically what it is it's just a scanner that uses the camera in your phone. You take a picture of your homework assignment on the desk, take a picture of it, and it converts it into a scanned PDF that you can upload to Blackboard. I actually went through step by step in that one video how to do that. And so everybody in here, if you don't have a scanner, should download that app. Make sure that you register with your EDU, your Marshall email address, because you get a couple features for free. And to be clear, Cam Scanner is 100% free. It's not, you don't have to pay for it. So so it's a pretty nifty tool. And I'll also mention now, and this is the case throughout the semester, if you all ever have any like technology issues, if there's some things that aren't working, just email me and let me know, and we can work through it. Mr. Atkins.
If I remember correctly, during the last semester, or it may have been last fall, I can't remember, but there was an incident with a cam scanner where I think people were hacked with it. What happens if we have a similar situation again? Or
That's a good question. So if something like that happens, or it becomes, let's say Cam Scanner becomes compromised, or you don't want to use Cam Scanner or whatnot, there are other options. For instance, Microsoft has a similar app. It's called Microsoft Lens, Lens, and it basically functions the exact same way that Cam Scanner does. It's just the Microsoft equivalent, so you can use that. That would be one option. Another option is if you're here on campus and you just don't want to use an app, you can go to the libraries or to, let's say, the engineering office and just physically scan it. Those would work as well. It's a bit more cumbersome, but there are other options. That good? And to be clear, anybody has a question, you can use the raise hand feature and just, you can throw something in chat. I'm the easiest guy in the world to get along with. I definitely want to be here answering your questions. Is that good?
yeah, it's good.
Okay. Awesome. All right. Let's talk about Microsoft Teams. If first off, I would wager that most of you probably already have Microsoft Teams installed on your laptops, and if you don't use it, you probably just don't realize it. It's come with the Microsoft Office 365 package. But Teams is a pretty valuable tool for one-on-one meetings. So for instance, if I assign a homework assignment and you have some questions, we can meet one-on-one through Teams. We can screen share. I can use my camera, and we can even do the problems on the whiteboard if you would like. However, we want to work through that. It's a really useful tool. There's a couple of other features that are going to make Teams pretty valuable. First off, everybody in here has already added to a class channel for structural analysis. So I might use Teams periodically to just send some quick announcements to the class, like, hey, I've graded homework 2.2, check Blackboard, and you've got some specific feedback on that. We can also use it as a backup for live lectures in case for some reason Blackboard decides to crash on us. I can send everybody a message like, hey, we're going to meet on Teams today because Blackboard's giving us issues. And then that happens, you know, that happened last semester. I'm just using that from experience. One other feature that we're going to use that I actually just discovered that this morning, and it's pretty nifty. If you go onto the Teams channel, there's what's called a class notebook. And I created a class notebook for everybody. And the reason why that's valuable is I've been teaching structural analysis for a number of years now, and one of the things that we'll do in class is we'll have a problem, and I'll be doing the problem on the screen. So I'll use the OneNote or the software to do the problem on the screen, kind of like what you would see on Khan Academy. Well, I can do that through Microsoft Teams, and everybody in the class will have access to that. So it'd be like everybody would have access to the not only the class notes, the lecture notes, but literally what I write on the board. And so Teams will be a pretty nifty interface for that. So I definitely want to give that a shot. I'm also going to be recording the lectures as well. I'm recording this one now, so you all will have access to that. Some other software packages. So of course, browser, I'd recommend that you use Chrome or Firefox. I'm actually using Firefox now, and it's working beautifully. Microsoft Office, make sure you have that. Make sure you have Adobe Reader, which is the just to open PDFs. And finally, later on, we're going to explore the use of a program called RISA 2D. And RISA is RISA stands for Rapid Interactive Structural Analysis. It's a software program for structural analysis, and we're going to use that later on in the semester. We only need really the demo, so I'm not going to make you pay for that. If you go onto Blackboard, there are instructions to download it. Admittedly, it's a lot easier to use on a Windows machine versus a Mac. So if there are any if you have any questions or whatnot, we can work through that. There's a link on Blackboard for if you have a Mac, some instructions to help you install that. But again, I'll mention it is easier on Windows. But that's not till way later on in the semester. We don't need to worry about that right now. For now, we'll just be using this interface like we see here. Are there any questions before we get into the grade and the syllabus and all of that? I'll give everybody a minute.
Lectures. Will they be posted on YouTube or on Blackboard or both?
The short answer is both, and I'm going to discuss that here in a bit. I'm going to record all of the lectures, immediately through Blackboard, and I have them set up to where all the students have access to access those recordings and even download them. I do plan on posting them to YouTube, but because there could be a little bit of a lag. The software that I was using last semester would automatically post to YouTube. But the problem is, because we're doing this virtually, we're doing it through Blackboard, that software doesn't quite work as well. So you end up having to download it and then manually upload it. I'm still going to do that, but if I don't do it like immediately, like just give me a few hours, or it might be uploaded the following day or something like that. Any other questions? Okay. Let's talk about the grade. So I haven't changed my grade distribution for the class, even with our move to virtual. I thought for this class that what we're doing makes a lot of sense. So we're going to have attendance be a modest portion of the grade. It's going to be 5%, and I'll talk about how I'll take attendance here in a bit. The homework I have here, of course, I think I have a typo. That homework, I have it as 30. Yeah, that's a typo. It's supposed to be 35%. Sorry about that. Homework is 35%. And then each of the 3 exams are 20%. Homework being the most massive part of the grade, simply because that's kind of how you learn structural analysis. I mean, you kind of learn it by doing it, and so I want the homework to be a big component of that. Let me talk a little bit about the textbook. So the textbook that we're using is the 5th edition of Casamali's textbook, and I'll just give you my general policy on textbooks. There are a number of ways that you can get the book. You can rent it digitally, and what have you. I am not one that's going to say, okay, you must buy this book at the store. You must have a physical copy. I mean, first off, we're in a virtual course, so I don't know how much that really matters. I'll say 2 things about the book. I do think it's a good idea for you to have a structural analysis textbook. I'm not desperately saying it has to be this one, but I do think it's a good idea to have that resource. A lot of what we discuss, I mean, hasn't changed since the apple fell on Newton's head. But there are some, but there is one point I would mention, is that while I don't care that you buy this book or that you buy this edition or whatnot, I will say that the homework is going to come out of this edition of the book. So my general policy on textbooks is that as long as you're able to get the homework done, I don't care if you rent the book. I don't care if you and a friend go half in on renting a book. Like, that doesn't bother me. You can do it however you want, just as long as, if I have a homework assignment due Wednesday at 10, that you're able to get the homework done. And if some of you are purchasing this and it's still in the mail, I mean, I can help you all out with the problems for the first maybe week or so while it's in the mail. But like I said, I'm pretty loose on that. So let's talk about the attendance. So the way I'm going to record the attendance is I'm just going to use the log that's on Blackboard. So the way that Blackboard works is anybody who logs into the system, it records who's logged into the system and for how long. So just make sure that you're on time and make sure that you stay for the total lecture. So, for instance, I see here that there's 21 students logged in right now. But if I look and I find that, you've only been logged in for 2 minutes, I don't know that would count as a full days of attendance. Now, let me be clear. I am the easiest guy in the world to get along with if you've got technical issues, if you've got, like if your internet went out at your apartment and you can't log in. I'm not going to hold that against you. I'm pretty easy to get along with that. But because I'm recording the lectures, I'm posting all the lecture notes. You have access to what we write on the board. You have access to all the assignments. You're still going to be responsible for the work. but I won't hold it against you if you've got any technical glitches or issues on that side. I'm not going to hold that against you. In regards to lectures and the lectures themselves, like I said, I am going to record the lectures. And might ask is, I know this happened a bit when we went online in the spring, is that my complete and total intention is to record every lecture, but sometimes I'll get started, I might forget. Don't hesitate to put in chat or to put on audio, hey, Dr. Mike, did you forget to record? And I'll hit record. So make sure that I remember to do that. The recordings will be posted on YouTube as well as available through Blackboard. It might take me, it might not be immediately available, but I will post them. That is my intention. If you go to the course content page in Blackboard, you'll see a link and it says YouTube playlist for the class. Now, right now it's empty because this is day one. But as the semester progresses, you'll see videos be posted to that YouTube channel. Let's talk about homework. This is something that I did last semester when we went online, and I found ultimately that the students responded well to it. And so I'll talk a little bit about that. Usually what I do in my face-to-face classes, before all this went down, is that I would have a very small number of homework assignments, but they would be rather large, and they would be really focused assignments. So for instance, we would have a homework on truss analysis, and there would be, like 5 or 6 truss analysis problems that would be pretty big. And it would take, I'd give you like a week or two to finish it, and they'd be pretty big assignments. When we went online, I said, I don't think that's going to work because I want to make sure that everybody is engaged in the lectures. So what I'm going to do is, instead of giving you these super huge homework assignments that are only due periodically, I'm going to give you a homework assignment like every day. And what I mean by every day is, so I don't have a homework assignment for today, so don't worry about that. But let's take Wednesday. So Wednesday's lecture is going to be focused on structural classification and determinacy. So we're going to have a lecture on just that. And then I'm going to give you a homework assignment on just that that's going to be due Friday. But it's not going to be hours and hours and hours of work. This particular assignment you can probably finish in, 10 minutes. It's not intended to be a work-intensive assignment. It's really just meant to keep you engaged and keep you motivated and the work. They're really designed to be pretty short assignments. And so instead of giving you a lot of homework, do at these specific intervals, I'm going to give you very small amount of homework, do more frequently, just to make sure that that you're motivated to stay on board. And plus, the other idea is, okay, let's say you miss an assignment. Well, it's not really the end of the world if you miss one assignment, because there's so many of them. And so last semester, I found that a lot of students, they actually really responded to that. They liked that system. It worked out pretty well. So I'm gonna keep on with that. As for the homework format, I'm pretty easy to get along with that. I do want you to use either engineering paper or like copier paper, like 8.5 by 11 copier paper. The reason why I suggest one of those two is purely because of Cam Scanner or your scanning app. If you have, like the high contrast between the paper and the ink, it makes the scan come through clearly. And so, like, whether it's engineering paper or it's white paper, the scan comes through pretty clearly. As for formatting, what I want is, I want the handwriting to be neat. For your figures, please be sure that you use a straight edge, that you're using a ruler or I don't know, like an ID card or something to draw that. Make sure that on the top of every page that you have your name, the CE312, the homework number, and the pagination. So this is like page 1 out of 3, page 2 out of 3, page 3 out of 3, so that you can scan that and send it in, and I know whose homework I'm looking at as I grade. Typically, you're doing a particular problem, you'll have the problem, do the work, and as long as you clearly indicate the answer, like you box your answer and let me know, okay, this is the answer, then that's going to be fine. I didn't have that on the slide because sometimes the answer is not a number. Sometimes the answer is a figure. So for instance, when we draw a moment diagram, the moment diagram is the answer, and it's pretty easy to see, okay, that's the answer. But if you're doing a deflection problem, the answer is 1.2 inches. So make sure you circle, okay, 1.2 inches and indicate that's the answer. For late homework, I have a late homework policy, but it probably isn't going to really matter very much because, like I said, homework's going to be so frequent that, like I said, if you miss one, it's really not that big of a deal. And I'm also going to post solutions to all the homework assignments. So it's like once I've graded the homework and returned the homework and given you the solution, it's like even if I gave you the chance to do it, I mean, it would already be done. But again, because there's so many assignments, I don't think any one homework is really going to be big of a deal. As long as you're keeping up with the work, you're going to be fine. And I don't really think that any of the assignments are going to be super difficult. Again, it's really just trying to make sure that you're engaged and keeping up to date with what we're doing. Let's talk about exams. I don't like that term. I tend to call them celebrations of learning. So we're going to be celebrating 3 times this semester. 2 of them will be during the semester, and the 3rd will be during the university final exam slot, in December. I have here that the exams are not intended to be comprehensive, and I mean that. I'm not really. I usually am not a comprehensive exam guy. In most of my classes, I don't do comprehensive exams. But there are instances where some of them carry bleed over from a previous. An example of that is, let's say, trust deflections. So in order to determine the deflection of a trust, which is a topic on exam 2, you have to be able to solve a trust, which is the topic on exam 1. So it's not like I'm intending to, recap the material on exam 1, but this course does sort of build on itself as you go from week to week. The stuff that you learned in week 4, you need to be able to apply in week 5, and that sort of builds. That's just sort of the nature of the assignment or of the topic. So yeah, again, I'm not trying to make them comprehensive. I'm also while the exams are going to be timed, I am not a time critical professor. Like, I'm not the type who will give you a 6-hour exam and only give you 50 minutes to do it. I've never really been that way. I tend to apply a rule. I call it a rule of 3. So for instance, if we have an hour to do an exam, I say, well, I'm not going to give you that exam unless I can do it in 20 minutes. So I sort of apply a rule of 3. And I actually sit here, once I make the exam, I do it myself. And if it takes me longer than 20 minutes, I'll cut material out so that I can do it in under that time frame. And so that's the rule I've always applied. And I've never really, I don't think I've ever really had any students complain on my exams being time crunches. Yes, sir.
Now, on the questions on the exam, will it be a mix of short answer, multiple choice, problem solving, or what's the setup going to look like?
That's a fair question. Typically what I do on exams is I have a mixture of conceptual questions and computational. So I will have a series of short answer questions, and then I'll have a series of computational, like, workout problems. I don't really tend to do multiple choice questions at least in this class, because it doesn't really make sense with what we're doing in here. What we're doing in here is, here's a structure. What is the deflection here? And so I could give you a multiple choice question, but in the end, you're still going to have to do all this work to get this answer. Now, one thing I'll say about, since we're talking about exams and talking about homework, I'll say about grading. It's been sort of a point of pride with me that I do my best to be as fair a grader as possible. For instance, what I'll do during an exam is let's say there's a deflection problem, and that problem has, I don't know, 8 or 9 steps. I'm just making this up for discussion purposes. I will build, let's say, an Excel spreadsheet for every student in the class, and I'll say, okay, here's the answer, here's what you got. And I'll go through, and if it's like a 9-step problem, I'll see, okay, they have an error on step 2 and step 5. And so those are the only deductions I'll make. As long as I'm arriving at the same answer you get, I'll only take off for those points. And I really, it takes me a long time to grade an exam, but as a result, I think I'm pretty fair. I really try and make sure that I'm not, unfairly deducting points. But I also don't, as a result, I also don't really curve. I don't really curve. You sort of just get what you get. But again, I've never really had too many students say that this is a terribly difficult class. It's a pretty systematic course. It's again, it builds on itself. It's a lot of common sense stuff, But yeah, now I went a little bit off on a tangent, but did that answer your question? All right. Before we do, I guess, a little bit of our final topic, are there any other questions about grading, about the course, about the exams? Oh, I did want to pull up the syllabus real quick. I forgot about that. Let me pull that up, and then we'll open up to questions. Let me stop the share here. Pull the syllabus up. Okay, so here's the syllabus. One thing I'll mention, everybody in here should probably take some time and review this. I have this uploaded to Blackboard as well. A lot of this, I'm going to breeze through kind of quickly because I've already talked about it. Again, the homework, that is 35%. That was an error on the slide. I'll fix that and re-upload the slides later on. But yeah, 35% for the homework and then 20% for each of the exams. Let me go to the next slide. I have here just some data on emails, Microsoft Teams, and Blackboard. I mean, again, I've already talked about that. There's some info on the technology. I think hopefully everybody in here is fine, that we've kind of already sorted through the technological issues. But if there's any issues that you have, I got a boatload of links in this section of the syllabus for the Design Center and whatnot, in case you have any issues. I have here just the attendance policy, the honor academic dishonesty policy. Again, this course really isn't designed to be too terribly difficult, and I have no problem with, if you need help, if you want to work together, that's fine. Just as long as you're doing your own work, I mean, again, I don't think that this is too much of a challenge. Let me get into the actual schedule. Before I do that, one thing to mention, I put this in my syllabus as page 5. This is additional COVID information. You're probably going to find that just about every syllabus at Marshall includes this semester, and I understand that a lot of this doesn't really apply to our class because it's virtual, but I would take a look at it and make sure that you understand what's going on, and if you haven't signed your return to campus agreement, make sure that you do that as soon as possible. Let's look at this though. This is the schedule for the semester. Now, again, like I said, there's going to be a homework assignment just about every day, and so I have those numbered on the very right. One thing I'll mention is that this is my projected homework schedule for the semester, that I'll probably have assignments every day. I probably won't add to this. If anything, I might subtract from it. In other words, if we have a topic that's taking a little bit longer, for instance, the deflection problems are not hard, but they can be a little long. And so if we're at a point where we're not quite finishing that topic, I'm not going to say, oh, well, we haven't finished the topic, but I have to give you an assignment because I said I would. I might just cancel an assignment and do it later. There's a couple points later on where the assignments get a little more spread out, because of the fact that end problems get, again, a little bit longer. A couple other final points I'll mention about the schedule. One thing I will probably be pretty strict about is the exam dates. Like, I could go ahead and tell you exam 1, unless an earthquake happens or something, will be on Wednesday, October 7th. On Monday, October 5th, we'll have an exam review session, and what my exam review sessions consist of is I'll come in for about 5 minutes and just tell you, okay, here's what we're covering on the exam, here's the format of the exam, here's what, generally what it's going to look like, and then I just shut up and let you ask literally whatever questions you want. And if I can answer them, I will, and we can go through problems, we can talk about the exam, we can talk about topics that we've discussed. It's really sort of on you. We can talk about whatever you want. The second exam I have scheduled for the Friday before Thanksgiving break. Depend upon where we're at, what I might do is I might move that exam up to Wednesday. So we might do our exam review on Monday, our exam on Wednesday, and then we cancel class on Friday. I can probably suspect that many of your classes are going to have exams like the Friday before Thanksgiving break, and I have it tentatively scheduled that I'm no different. But I'm a big proponent in giving an exam when it makes sense. when the material is fresh in your head and when I want to see you do as well as possible. And what I don't want to have is, we covered a topic in September, but we don't test on it until November. I want to make sure it's fresh in your head and that it's the appropriate time to do it. So the only thing that I could probably predict that would happen to the exam schedule is that I may move that second exam early so that we can maybe cancel class on Friday. But again, I won't do that if we're falling behind. We'll just have to play it by ear. All right. Now, before I get into the last sort of bit of topic for discussion for today, now I want to see if there's any questions about the class, about how we're going to operate things, and anything. Floor is yours. Yes, sir.
I noticed that over the past year or so is that the semesters are getting shorter. What content has been cut out from your original schedule because of this?
That's a good question. For this class, there was really only one topic I cut out, which is a topic at the very end of the semester called moment distribution. And we might actually try and incorporate it depending upon how things go. So my goal for CE 312 is that we fully and completely cover statically determinate structures. And we've never had a problem with that, regardless of whether it's 15 weeks or 14 weeks. The question is, when we cover indeterminate structural analysis, how much indeterminate analysis do we cover? What I used to do in a 15-week semester is I would cover two topics. I would cover moment distribution, and then I would cover matrix analysis. And what I've pretty much decided to do is convert solely to matrix analysis. And the reason for that is that matrix analysis is how structural engineering software programs run. They use finite elements and matrix analysis to perform structural analysis. So I figure if there's one topic we're going to cover, that's the one that'll make sense. So while I cut topics out at the very end, it really never affected the main goal of the class, which is to fully cover statically determinate structural analysis. So that's all of the reactions, internal forces and structures, the deflections, influence lines, all of that we've been able to cover no problem. But that's a fair question. And in some of my design courses next semester, it was sort of the same thing. It wasn't cutting out the main topics. It was just some of the little cherries at the end that weren't that big of a deal, would be the best way of describing it. Any other questions about the class, about what's going on with virtual classes? Anything I can answer about, anything? Floor is yours. All right. Okay, so Mr. Randolph asks, if we don't get to cover a particular topic, would you be open to providing course notes? Absolutely. I have no problem with that at all. Not only that, but I've been teaching this class for a number of years, and I not only have the course notes, but I have recordings of when we've covered it in previous years. So no problem at all. Other questions? Yes, sir.
You said moment distribution was something you had to cut. Would that be possibly a bonus question on the final exam or exam 2? If pushing it.
It depends on where we're at. My general teaching philosophy is that down to it, the topics that we cover, I want to cover well, and I don't want to rush a given topic, because it's like, if I rush a bunch of topics, I didn't really cover any of them rather well. I'd rather call the ball and cover one and cover it well. Moment distribution is it's possible. It just depends on where we're at with timing. The main reason that I chose to cover moment distribution is because it's a really nifty trick that you can use to quickly analyze indeterminate structures, but B, it has some very close parallels with a method that you use in hydraulic engineering to do flow and pipe networks. When you there's a method, the Hardy-Cross method, for flow and pipe networks, where you assume a series of flows and then you keep iterating your solution so that flow in equals flow out, and you keep doing that until you can see that the answer converges. And you basically do the exact same thing for indeterminate beams in moment distribution. And so I covered it because it was kind of nifty, but it really tied into to something that you do in hydraulics. But in the big picture, matrix analysis is far more important, and that'll become clear as we get near to the end of the semester. So I'm not opposed to that. It just, I don't want to sacrifice covering the necessary topics well. Focus on doing a good job on the topics that we need to cover instead of rushing through a bunch of stuff at the end. Any other questions? All right, I want to close the topic today by something that I like to do with every class that I teach, and that's answer why the heck are you even in this class? Because I remember these times I was in grad school and I took this class called Continuum Mechanics. I'm sitting here going, why am I in here? This is, difficult. Like, it doesn't, I don't see the benefit towards my field. And I feel that, if you're going to spend your time, your money, and your energy trying to, understand the material in this class, you should have a good understanding as to why you're in here. So why are you taking CE 312? Okay, well, let's talk about that. First off, maybe we should define right at the very beginning just what is structural analysis, okay? And you could go to Google and you could open up a textbook and you could find all sorts of belabored definitions for what exactly structural analysis is. If you want a short and sweet definition, though, I'd say that structural analysis is we as engineers are determining effects on physical structures and systems when they're subjected to loads. Okay, and so regardless of whether we're talking about buildings or bridges or transmission towers or oil platforms or what, it doesn't matter. Whatever system that's being subjected to physical loads, what is structural analysis? It's determining the response of that system to those loads. And so what do I mean by effects or responses? I mean things like the support reactions. I have a structure, it sits on the ground. What are the forces on the ground that keeps that structure up? I'm talking about the internal forces and resultants inside the members. So if it's a truss, we're talking about the forces inside the truss members. We're talking about shears and bending moments, all the internal forces that are developed as a result of keeping that structure in equilibrium. And then ultimately the structure's deformations, right? Any structure that you apply load to deforms, right? You put a load on it and it deforms. Understanding those deformations are incredibly important. How much it deflects, how much it rotates, those are all incredibly important. And like I said, structural analysis is the determinant of the response when it's subjected to loads. And what do I mean by loads? Well, really in structural engineering, the two primary loads that we deal with, there's gravity loads. So gravity loads are loads that act up and down with the direction of gravity. So we're talking about the self-weight of a structure. So I'm in the engineering building, I'm in my office. So, obviously the self-weight of the building, this is a structure made of steel and concrete and has all sorts of, wall appurtenances and carpet and all that stuff here. All that is applying load to the system. The steel frame that holds this building up has to be strong enough to hold up those loads. There's also occupancy loads. Sometimes they're called transient loads because they move around, but in structural engineering vernacular, we call those live loads. So in a building, we're talking about me, we're talking about the furniture, we're talking about the people that are applying load to the floor system. If we were talking about bridges, we'd be talking about the vehicular traffic and the exclusionary vehicles, the truck traffic, the concrete cement mixers, all those vehicles that apply forces to the system. So the first type of loads that we deal with as structural engineers are gravity loads. The second is environmental loads. And environmental loads are things like wind, things like earthquakes, like seismic effects, and then rain, snow, and ice. And really the key one there is the snow that accumulates on roofs and whatnot. That's really where we get our structural impact. Now there's other effects that go into the structural analysis. For instance, temperature effects. If you have a bridge, that bridge heats up and cools down over a given day, and that causes expansion and shrinkage of the system. For instance, there's dynamic effects. If you've driven on roads in West Virginia or really any other state, there tend to be these things called potholes. And when you have potholes and you have vehicles that drive on them, they don't just drive on the road, they bounce the road. And that dynamic effect increases the response on the structure. And so all those different aspects need to be taken into account. Now, okay, so that's what structural analysis is. We have a system, we have a load or some effect that's being applied to that system, and structural analysis is determining the response. Well, who cares? Why do I care about that? Well, the answer is to design. Okay, I mentioned earlier I'm in this building and I'm in the second floor, so I'm standing on floor beams. Well, I want those floor beams to be strong enough to hold me up and strong enough to hold the system up. And I'm not going to be able to do that unless I understand the forces and the response of that system. By understanding the effects in beams and the columns and whatnot in this system, I can then appropriately size those elements so that they can safely support the system. So for instance, if I'm looking at this bridge on the right that's in China, this is a railroad bridge, and you can see there's the bridge and then there's a series of piers. Well, how do they determine how many piers that you need? Or if I'm looking at this building on the bottom left, how many columns do I need? How many beams do I need? How far apart do I space them? How big or how deep for each of the beams? What's the size of each of the columns? All of that comes from structural analysis. By understanding the forces, the moments, the deflections of each of those elements, I can determine, well, what elements do I need to use so that that structure is supporting that load safely. And that's really why we're in here. Where do we start? Well, we start off with a couple of things. First off, we need to adopt some basic tools. So equilibrium. We need to use the principles of statics, which I know some of you might hear the word statics and again, it's the onset of a acute post-traumatic stress disorder, but I promise you that the statics that we use in here is very basic, very straightforward. You won't see, for instance, any IJK or any dot cross products, anything like that in this class. It's pretty pencil to paper, pretty basic stuff. The math is pretty straightforward, so I don't want that to scare you. So we'll need equilibrium. Mr. Wise, I see there's a question. Did you have a question, Mr. Wise? Or are you? Oh, that's okay. That's all right. So we'll need the tools of equilibrium. We'll also need constitutive relationships. So that's your stress strain curve. So your stress strain curve for steel or concrete or those different materials. We also need to understand compatibility. So when we have a structure and it deforms, those displacements need to be continuous along the structure. And those three tools are basically the three primary tenets that we use when we perform structural analysis. But that gets to a little bit of I guess, a quirky specificity to indicate. We call this class structural analysis because you would think, well, we're analyzing structures. That's not technically true. Instead of analyzing structures, what we're doing is we're analyzing and developing models that represent structures. Structures are complicated. I mean, they're complex three-dimensional systems. They can exhibit dynamic behavior, nonlinear behavior. They can buckle. I mean, there's all sorts of complex stuff going on with structures. And the idea is that you look at some of the systems that we design, and it's kind of impossible to do some of that design and even that computational modeling exactly. Instead, what we have to do is make a series of assumptions and then develop models based off those assumptions. So for instance, if I've got this roof truss system on the left of this slide, that's not really what I'm analyzing. What I'm analyzing is this thing on the right. And this thing on the right, there's just some lines and some arrows and this symbol at joint A and this symbol at joint G that encompass some behavior. And the idea is that the behavior that we attribute this analytical model represents the real life behavior of the structure as closely as possible. And so that may seem like a a hair-splitting point to make, but it's actually incredibly important as a structural analyst. Applying the appropriate model to the problem that you're looking at is one of the biggest challenges that structural engineers face. But we'll get into the details of that later and a bit more in depth as the semester starts. What we're going to do on Wednesday is we're going to pick up this discussion of analytical models. What I want to talk about is how we classify those models, how we develop those models, what it means for a structure to be stable, what does it mean for a structure to be statically determinate versus indeterminate. I sort of threw those words out today, and I didn't really get into the what it means, and we're going to talk about that on Wednesday, and we'll have an assignment that goes to that. But that's pretty much where I want to end today. I wanted to make sure that everybody was clear on the course operation, the software that we were going to use. I wanted you to have a little bit of a motivation as to why you're even in this class. I'll sort of open it up to see if there's anybody else that has any questions, anything I can answer real quick before we close off for today. Well, all right. I have my office hours as Monday and Wednesday from 2 to 4, and from Tuesday, Thursday from 10 to 12. But if you need anything, please feel free to contact me. Send me an email. If we need to chat via Teams, we can. There's no homework for today, so that's pretty much it. That's all I have. I look forward to having everybody in class. And again, we will begin our sort of full discussion of structural analysis on Wednesday. That's all I have, everybody. Have a wonderful day.